Hi, hello everyone. So today we will work on the level prac manual synchronization to grade. So the training objective is put a three-phase synchronous machine into operation as a synchronous generator, manually synchronized to the grid by means of the following methods. First, dark lamp synchronization. Second, bright lamp synchronization. And finally, three lamp synchronization. Determine the exact point in time where synchronization occurs using control lamps and various measuring instruments like a dual-range voltmeter or synchroscope. So first, we will work on the synchronization to grade using dark lamp synchronization method. So as you can see here, today we are using this platform. This is a module controlling the servo test machine. So the servo brake system is driving the synchronous generator here, the orange color device. This part is the excitation circuit. So while controlling the exciter current, we can control the output voltage of the synchronous generator. And here this part is, this module is the synchronization unit, which can measure the voltage for both sides, external grid side and the generation side. So those voltage meters can measure the difference. And this is a frequency meter, can measure the frequency for both grid and generator. So now we will start building the circuit by referring to this diagram. So this is the circuit diagram, and we will establish the connection first.
We don't have the 113. We've got we don't have Luke's and all of our songs. That's like obviously right here. Does it work?
No, I actually ended up finding my old one anyway, but the new one doesn't work. What is in my bed?
Yeah, see. Okay, it does. We're going to move to there's the one which was talking about the classes today. Like a lot more on the time sheet.
Yeah, we use them.
Yeah.
You get some.
Yeah, I'll get it.
I'll grab the food or some cases.
I can't find any potential, is it? I don't need it.
Or is it, do you want to try and do both parts today? Just get all of them done.
Yeah, we want to help today with I told him, like, obviously all we've done is change the size. Why don't we
You don't have to change the whole drawing, you just have to change the dimensions in the whole drawing.
Yeah, that's what I was saying. He's like, no, I spent 6 hours yesterday.
He's not. He over exaggerates the amount of time he spends on shit. Every time. This is cool. What's up?
Well, have we actually changed anything? Obviously,
We only changed the spherical joint size and then the actuator size. Everything else staying the same.
Like, are we changing geometry or just sizing?
Just sizing.
Why do we have to go through and do all that then?
No, well, if you change the size of the actuators, you're gonna have to change the size of
No, I'm talking about the drawing. So, like, don't redo the whole drawing. So
Yeah,
actually
I know.
just.
Hey, literally, you have to do it just for the. Yeah, I don't know. What are you trying to look for?
There's alligators.
I reckon I'll use that. Yeah, one. Right. What do they keep?
There used to be a good talk about the Is that the new Raspberry 4?
It's not.
Raspberry Pi 4? Wi-Fi?
What do you do? Oh, it's just like this thing.
I don't even know what's Yeah. Yeah, yeah, we do 5.0.
Crap.
That's all the voltage. You can't even do that subject. Yeah.
Yeah, I know.
So how many alligator clips do we need?
Six.
Yeah, a couple of Yeah, these ones so bad.
Well, why still alligator clips though? Like, what do you get?
Oh, we got one now. Two.
Damn, someone melted this shit so bad. Someone started a fire.
Yeah, this one's sold off.
Is Joe in it?
No, they're pretty safe. Okay.
Standard.
Yeah, I wish I could do it better.
I don't understand the amount of flip flops.
Right, how many did you say you had on the bench?
These are potentiometers.
Oh, the potential is it? Oh, man.
What is this for?
You just do like a converted inputs. And then we try different like inputs.
You just turn that on the signal generator.
It's just a more smooth way to do it.
Do you want how many?
I think we need two. Two inputs.
Now I have finalized building the circuit by referring to the diagram in the document. So now we follow the steps. First, use the servo brake as a drive motor for the synchronous generator. So the servo is already connected to the generator. Select the synchronous mode on the breaker's control unit and start the drive motor. And now let's start the servo brake system. Now I have selected the synchronization mode on the brakes control unit. For the rotation speed, simply set the synchronous speed of the generator on the control unit. So here for the synchronous generator, there's a nameplate here. On the nameplate, it shows the synchronous speed is 1500. So now we need to set the speed for the servo brake system as the synchronous speed 1500. Now the speed is 1500. Switch on the DC power supply. So the DC power supply for the exciter circuit is on. Adjust the exciter current with the aid of the exciter control unit such that the generator voltage corresponds to the line voltage on the grid. This exciter voltage level can also be used at the start of other experiments. So now we need to adjust the exciter current here by adjusting this knob in order to have voltage output, the voltage output from generator the same as external grid. So now they roughly the same, those two voltages, as you can see here. So those voltage meters shows the voltage for both sides same as each other. Carefully adjust the speed on the control unit of the servo brake until all the incandescent lamps go out. So let's slightly adjust the rotating speed here with slightly decrease. Then you can see there is a frequency difference between synchronous generator and the external grid. Here you can see the light. The light is getting dark and bright alternatively. So this means the sequence of the three phases for the grid side and the generator side, they are different to each other. So the sequence of phases are different from each other, then we need to adjust. If their sequence of phases are the same to each other, the three lights should get dark or bright simultaneously. So now we need to adjust the sequence between the grid side. For the grid side, we adjust the sequence of phases. Now I have switched the first phase and the second phase for the grid side in this connection. So now you can see the three lights getting bright or getting dark simultaneously. So this means the sequence of three phases are the same for both sides. At the right moment, when all the lamps are off simultaneously, turn on the power switch of the synchronization unit to connect the generator to the grid. So here this is a synchronoscope meter. So this meter is showing the phase difference between two sides. So when the two sides, the sequence of when the two sides, the phase are the same, so here the green light will be on. And at that moment, the lights are all dark simultaneously. So now I have switched on the connection between grid and the synchronous generator. So now my synchronous generator is connected successfully. The synchronization process is thus completed. Increase the drive power of the generator by setting the drive torque of the drive motor of the machine test system to approximately -1 Nm. Now observe the generator. So now, as you can see here, I have set the torque for the servo brake system as -1. Now it's -0.99, so almost -1. So you can observe what's happening here for the synchronous generator. So actually, nothing happened here regarding the synchronous generator. This is because the output voltage, the frequency is synchronized to the external grid. Our input here, our torque here, does not obviously change the operational status of the generator. Afterwards, disconnect the generator from the mains again and stop the drive motor. We disconnect now. Switch off the excitation as well. This part of experiment synchronization to grid using the dark lamp synchronization method is now concluded. Now let's work on the second experiment, synchronization to grid using the bright lamp synchronization method. So again, we need to rebuild the circuit by referring to this diagram. This diagram is given in the document uploaded to the GCU, so you can refer to the diagram there. So here in the level prac 1, the three lamps are measuring the voltage difference between each phase. For it, each lamp is measuring the voltage difference for each phase between the grid side and the generator side. So this was the previous connection, as you can see. This is black color is phase A, yellow color is phase B, red color is phase C. So now for the experiment 2, we need to change the connection here. Here, for the bright lamp synchronization method, the lamps, they are measuring the voltage across two phases. They are measuring the line-to-line voltage for two sides. So here you can see now the connection for the bright lamp synchronization method is completed. So for the first lamp, for using the darker color banana cable, this lamp is measuring the voltage between phase A of grid side and the phase B of generation side. So this is line-to-line voltage. For the lamp number 2, using the yellow color banana cable, it is connecting between the phase B and phase C for two sides. The lamp 3 using the red color cable is connecting across phase C and phase A for the two sides. So use the servo brake as the drive motor for the synchronous generator. So we still use the servo brake as the driving system. Select the synchronization mode on the brakes control unit and start the drive motor. Now let's start it. We still set the speed as the synchronous speed, 1500. Now the speed is the synchronous speed. Switch on the DC power supply for the exciter circuit. Switch it on. Adjust the exciter current with the aid of the exciter control unit, such that the generator voltage corresponds to the line voltage on the grid. So here, adjusting this knob, make sure the two sides, for the grid side and the generator side, the voltage is still the same. Carefully vary the speed on the control unit of the servo brake until all the incandescent lamps are lit at the same time. So now we slightly decrease the frequency. As you can see, there is, because the two sides, there's a slight difference regarding the frequency. So you can see there is a phase difference and it's rotating. So when the green light is on, it means both sides, the phase angle is the same, and the light will be in the brightness mode. Increase at the right moment when all the lamps are simultaneously at their brightest. Turn on the power switch of the synchronization unit to connect the generator to the grid. So we wait when the lights are in the brightest mode. Actually, that is the same time when the green light is on here. So now it's switched on. The generator is connected to the external grid. As such, the synchronization is concluded. Increase the drive power of the generator by setting the drive torque of the drive motor of the machine. Test the system to approximately -1. Let's still do the setting here. So now the torque is set to -1. Observe the generator operational status changes. So because our generator is connected to the external grid, it's synchronized to the external grid, so the frequency is stable, the output voltage is stable. So when you change the torque here, there's no significant change in the operational status of the generator actually. Subsequently, disconnect the generator from the mains again and stop the drive motor. So now let's disconnect. Stop. So this part of the experiment, synchronization to grid using the right lamp synchronization method, is now concluded. Now let's work on the experiment 3. Synchronization to grid use the 3-lamp synchronization method. We need to build the circuit by referring to this diagram. This diagram is already given in the Learn GCU, so you can refer to the details there. So previously in experiment 2, we are using the 3 lamps, measuring the voltage difference between number 1 between phase A and phase B, number 2 between phase B and phase C, number 3 lamp between phase C and phase A. So now in the experiment 3, we need to adjust the connection of the lamps. So we slightly adjust the connection. So now 2 lamps are connecting between the line-to-line voltage, number 1 and number 3. 1 lamp is connecting between the single phase voltage, that is number 2 lamp. Use the servo brake as the drive motor for the synchronous generator. Now we are still using the servo brake as the driver. Select the synchronous mode on the brake's control unit and start the drive motor. Now we start. We still set the rotating speed as the synchronous speed, which is 1500. Now switch on the DC power supply. Adjust the exciter current with the aid of the exciter control unit such that the generator voltage is equal to the line voltage on the grid. So we have already set up before. So now the voltage for both sides is roughly the same. For both sides, the line-to-line voltage is around 400 volts. Carefully vary the speed on the control unit of the servo brake until the center line of the synchronization unit goes dark, and the other two outer lamps light up brightly. So we slightly change the rotating speed here to create an angle difference. So you can see now the brightness of the lamps are changing. As soon as this occurs, turn on the power switch of the synchronization unit to connect the generator to the grid. So we wait the moment when the two sides are synchronized to each other, which is the moment when the green light is on here, and also the same time when the two lights which connecting between line-to-line voltage are bright. When this light in the middle, which is between the single phase voltage, is dark. So that is the moment. So now our generator is synchronized to the external grid. Synchronization is thus concluded. Increase the drive power of the generator by setting the drive torque of the drive motor of the machine has system to approximately -1 Nm. So now let's set. So now we have set the torque as -1 Nm. Now observe the generator. Actually, there's no significant change happening here. This is because generator is synchronized to grid. Frequency voltage is stable. So even when you change the input torque of the servo brake system, the rotating speed of generator, frequency voltage are not changing here. Finally, disconnect the generator again from the grid and stop the drive motor. Disconnect. Switch off the excitation again as well. This part of experiment, synchronization to grid using the 3-lamp circuit, is complete. So now we have finalized the 3 experiment regarding using the 3-light method to synchronize generation to external grid. So please also finish the review questions in the document and submit your finalized report to the LearnTCU system. Thank you, everyone.